Welcome to the Campus Energy and Sustainability Podcast. In each episode, we'll talk with leading campus professionals, thought leaders, engineers, and innovators addressing the unique challenges and opportunities facing higher ed and corporate campuses. Our discussions will range from energy conservation and efficiency to planning and finance, from building science to social science, from energy systems to food systems. We hope you're ready to learn, share, and ultimately accelerate your institution toward solutions. I'm your host, Dave Karlsgodt. I'm a principal at Fovea, an energy, carbon, and business planning firm.
In this episode, you'll hear a live recording we made during a panel discussion at the Washington, Oregon Higher Education Sustainability Conference. I did want to mention that this panel ended up consisting of 5 white males, which was certainly uncomfortable given the racial and social equity themes at the conference. While this occurred partly due to circumstances beyond our control, I did want to call it out specifically. In the end, this was a healthy discomfort and led to some productive discussions with some amazing women, which I hope to capture and share with you in future podcast episodes. That said, I was honored to lead this discussion with some truly innovative thinkers and doers pushing the envelope on our approach to the built world. I hope you enjoy this episode, recorded Tuesday, February 26, 2019, on the campus of the University of Washington.
All right, I guess we're going to get started here. Welcome to our session. This is Building a Sustainable Future, Intersections of Energy Infrastructure, Student and Community Engagement, and Campus Design with Global Reach, which also is a mouthful since they mashed our titles together, I believe. So anyway, we are going to be recording this today for a podcast. My name is David Karlsgodt. I am a consultant. I work with higher education institutions all over the country. But today I'm going to be your host for this session, the moderator for this discussion. And we're going to be recording this as a podcast, so if you're interested in hearing the final product, and I'm hoping you'll all be involved with this today, and we'll get to that in a second. We've got cards up here, and you can see it on the screen. All right, yeah, so I'm based here in Seattle, just a few miles north of this campus, so it's a pleasure to be here. I'm going to introduce our panelists here in a second. And they're a great group of people, and we're going to talk about some interesting projects here on the University of Washington campus. But I want to get you guys warmed up a little bit first. You know, Devin's going to be talking, and he's going to be telling a great story about maybe how his son has inspired him to build a better future for the world. And you all are going to say, yeah, there you go. Okay, let's get getting warmed up. Maybe a little later, Chris is going to stand up, and he's going to give an impassioned oration on getting toxic materials out of our building systems. And you're all going to say, all right. Kyle, he's going to try to lighten the mood maybe, and he's going to have a one-line zinger, and you guys are all going to go. And then Chris is going to take it down, and he's going to decide that rather than give his normal introduction, he's going to do a beatnik poetry version of it, and you guys are all going to go. All right. We got a quick study here. Okay, so good work. I'll just start with a little bit of context, and then I'm going to introduce them. I have a few prepared questions for them, and then I'm going to try to turn it as much as possible over to your questions for this panel. Just a few high-level facts. So according to IEA, buildings are the largest energy-consuming sector in our economy, with roughly about a third of energy use going into our buildings. And I've seen another stat, which is roughly half to 75% of our buildings that we will have in 2050 haven't even been built yet. So this topic of how we build our buildings is going to be a critical piece of how we get to a sustainable future. Most of the buildings we have today were built in the second half of the 20th century, and that was definitely not a time where life cycle costs were really a thing. It was mostly about first cost. It was about building more, cheaper, faster. And today you're going to hear some different ways that that's being approached today. So there definitely are a lot of positive trends going on in this world. We have the LEED certification. I was on the tour yesterday and saw multiple LEED Gold buildings and some really amazing stuff going on. But I think what you'll see in this discussion is even that, it's doing less bad, but we actually need even more than that if we're going to build a sustainable future. We're going to talk today about 2 buildings here on the University of Washington campus, and I'm going to let them each get into a little bit of detail on that. And then we're going to try to broaden the frame a little bit, and that's where you guys will come in with your questions. So why don't you each introduce yourself briefly? We'll go through this pretty quickly, and if they get too long-winded, which architects especially can sometimes do, you guys will go, I don't know what you do. Yeah, throw something at him. I don't know. We'll see how it goes. Devin, why don't you start us off?
Sure, of course. So my name's Devin Kleiner. I'm an architect at Perkins+Will. And about 10 years ago, I started leading, in addition to being a project architect, I began leading our sustainable design initiative for the office, which has some great opportunities. I was able to work on quite a few innovative projects, a lot of them on the higher education side. So for example, down in Tacoma for UW Tacoma, all the way up for University of Alaska in Fairbanks, and then recently one here that we'll be spending a fair amount of time on. Also, I've been able to co-teach with Chris Meek here. There's a design studio for the last 2 years, looking at how we can look at performance-based design as a way to really drive the next generation of architecture. So I'll stop there. Was that quick enough, Dave?
That was good.
All right.
Good job. Keep it going.
So I'm Chris Meek. I'm faculty in the Department of Architecture, where I teach in building performance, sustainable design, design with climate. And I also co-direct with a faculty member and also in architecture named Heather Burpee, the Integrated Design Lab. And we are a group, we're up at the Bullitt Center, which is a net zero energy building. Some of you might have gone on the tour of that yesterday. We have a group that really is built around creating a bridge between the academy and practice. And we do that through education, outreach, and technical assistance, where we work on real world projects, and that informs our research agenda. So I also have a lot of involvement with buildings on campus, and I'm an ex officio member of the Campus Sustainability Fund group. And so I guess that's probably about enough on me for now, so I'll hand it to Kyle.
Hello everyone, my name is Kyle McDermott, and I'm the Campus Sustainability Fund Operations and Program Coordinator here at UW, and I'm also a graduate student, so I'm finishing a 3-year program in the Environmental Horticulture program and taking courses in the College of Built Environment, a PhD program that focuses on sustainable systems and prototypes. And part of that interest has sprung from my 2.5 years here with the Sustainability Fund and working with folks like Chris, Devin, Chris here, and working just with some really amazing people who are doing great work in the design field. And so that's kind of having the opportunity to be working with the built environment and working with my great colleagues here has showed me what design and the built environment can do, both through a inclusion and equity lens, as well as really bringing forward some innovative technologies that we were able to do with some of these projects we'll talk about today.
Hi, I'm Chris Hellstern. I'm an architect with the Miller Hall Partnership in Seattle here. I'm a sustainability director, primarily focusing on living buildings. That's my expertise. Been working on those for the past 10 or so years here. Fortunate to work with the University of Washington here on the building we'll discuss today. I'm also an affiliate lecturer at the College of Built Environment for the real estate program, teaching sustainability here at UW as well.
So let's start talking about these two buildings. You're seeing some of the images in the screen behind you here. We have both the population health building, which is still under construction, and then we have the life sciences building. Maybe we'll start with the life sciences building. And I learned today that this project just won this, Building of the Year in Seattle. Or tell us more about that, Devin. Maybe you can start there. Congratulations.
Thank you. So the life sciences building, we just found out this morning through the Daily Journal of Commerce, DJC. Throughout the year, they just collect several of the projects that they've highlighted, and they open it up to the public to vote on them, and we just found out this morning, so yeah. So the project, I'll just give a little bit of background on it, and we can certainly go in more in depth at a later point with your questions, but overall it's a 200 square foot building. There's a 15,000 square foot greenhouse as a part of it. It's for the biology department. It has a couple innovative features that actually working with Kyle has been a big part of that from this Campus Sustainability Fund, but I'll just highlight 2 of those aspects that actually were through a grant process through the Campus Sustainability Fund. One of them being solar fins. They're basically taking a solar film and laminating it between 2 pieces of glass and then putting it on the outside of the building. There's a southwest orientation, which many of you know is a really challenging orientation to deal with that low solar sun coming from the west. And so it was able to both shade the building, reducing heat gain, and it seems so logical now, but it also was able to produce energy. So the element that's both shading is also, of course, producing energy, and it's been made possible through some great collaboration with the student groups, as well as really a very forward-thinking client. Another one that I'd like to highlight as far as a feature is the rainwater reuse. The labs, through part of the purification process, have a reject water. It's about 20% of the water they typically would just go right down the storm sewer drain, get pumped out, use plenty of energy to get out to somewhere where it can get treated. But this is actually perfectly good water, just not good enough for the labs. So that is being stored in the basement and being reused within the greenhouses for irrigation. And so it's looking for synergies there where there's a waste from one part of the building can become a resource for another, or an orientation that can be a real challenge in trying to find some synergies. And if we start getting to the kind of cost component of this, how can we get what our project manager would call kind of these twofers, right? You get 2 for 1, how can we get multiple benefits? And then the costs start to seem a lot more reasonable. So I'll stop there unless there's specific items you'd like.
Maybe Kyle, I'm going to turn this one over to you. So maybe you can speak to your role with the Campus Sustainability Fund and how you guys, the solar aspect of that building in particular.
Sure. Yeah. So the solar piece was brought forward by a group called UW Solar on campus. So we're really lucky to have this group. They're based out of the College-built environment as part of the Urban Infrastructure Lab, and this group is advised by a faculty member, Jan Whittington, in the urban planning department, and then they have president and vice president who are typically either graduate or undergraduate students. So, and then usually between 20 and 30 members that work with UW Solar, volunteer student members. So a lot of what they've been doing is kind of cataloging processes for consulting and identifying opportunities on UW's campus, and then really creating a systematic framework where they can identify opportunities and just go through the process of carrying forward these ideas rather than kind of scrambling for, can we do this, or, where do we get the funding? They really have nailed down this process. So, and also the funding mechanisms were a really big part of this. So we were able to contribute some of the feasibility study funding, and with that funding, they were able to go to other sources. Unfortunately, in the last couple of years, some of the funding they had eyed between the Department of Energy and the Chamber of Commerce had dried up with the current political administration, but they were able to find a couple other sources. So they're really leveraging this funding to expand this project to be a really substantial infrastructural solar project on campus, unlike really one that we've seen before. So that was all through the work of this student group, UW Solar, in collaboration with the Campus Sustainability Fund. So
maybe I could just add one more piece to that. So one thing that the student group brought to the table is, in addition to the solar fins that are on the outside of the building, kind of on the facade, what about on the rooftop? Are there additional opportunities? So that was something which we had talked about, but as a team, we're not necessarily going to go forward with until that additional funding came along. And the great benefit to that is with standard solar panels on the rooftop versus this new innovative product on the face of the building, we can track the energy performance. In fact, the ones that are on the face of the building perform really well in cloudy weather. So we're able to see how is each one performing, and we're able to track what the weather is doing. And I think it'll be a good educational opportunity. And I really have to give credit to the student group to say, this is really important. We want to push this forward.
Great, thanks guys. Let's move on to the population health, and just give us a little background on some of the stats.
Sure. The population health building is being constructed right now on the west side of campus. It's about 300,000 square feet, so quite a large building. And it was funded through a gift from the Bill and Melinda Gates Foundation. Their idea was to really bring together 3 disparate health groups here on the campus that really have offices scattered around Seattle and around the campus. But the idea is to have them work together to really help to solve these global public health issues. Really quite a good idea. And so this building is designed for that, to bring them all together. So really quite a large facility, but we worked together with the Campus Sustainability Fund as well, and I think that's one of the great successes of the project, is really being able to reach out and work specifically with the university, the whole U group that's here as well on campus, but Campus Sustainability Fund as well, and really interacting with the students to get their ideas about what would make a difference to them and what they could use for educational opportunities, much like Devin's building as well. And I think those are some of the real great takeaways around that project as well. The building focuses primarily on health, as you might imagine. So there's strategies that really speak to that, looking at the FitWell certification, if you're familiar with that, increasing activity in the building, removing chemicals of concern from some of the products used in the building, and really focusing on the health aspect, daylighting, air quality, and those general principles that sometimes get left out of buildings too.
Well, Chris, we left you out of this opening round. Is there anything from your perspective, especially from the Innovation Lab, that you would like to add? I know you've been thinking about these kinds of buildings and some of these techniques for quite a while.
Yeah, well, I just think it's pretty exciting what's happening. And I want to reiterate and make it really clear what the Campus Sustainability Fund and the students and all of you, at least all of you who are students, are bringing to the table on this. Every time we build a capital project, budget is always a constraint. There's always challenges, and we have to figure out innovative ways to do more with less, to do 3 things with 1 thing, and make things happen. And a lot of times the things that get squeezed are some of the sustainability features. And for example, the solar piece. If it wasn't for the students who are taxing themselves and committing to creating a more sustainable campus, those solar panels wouldn't have happened, at least on the roof. And I think it shows that the commitment of the students here on campus at UW is really, really strong, and they're putting their money where their mouth is in terms of doing more work to get to a decarbonized campus and a lower energy campus. So it's pretty commendable what they're doing.
So Kyle, maybe you can speak to how some of these ideas have gone from, the ideas of students and then how you've been able to interact with these professionals on these projects, because I think that's an interesting story to share.
Sure. Yeah, so this originally came to us from the life science building. It was the water reuse system was brought by the director of operations for the biology department, and they wanted to do this project, but they didn't have a very heavy student involvement component. That's something that our committee prioritizes. So the director of operations for the biology department proposed creating an internship position for that student to work directly with the construction firm, Skanska, on this project. So they ended up creating 3 internship positions for the students to work directly with the design and implementation of that RO water reclamation project. And a few of those students actually ended up getting hired by Skanska. We heard feedback from them that they were out canoeing with them one weekend, and that partnership really worked out really well. So we wanted to kind of replicate this process. We thought there were a lot of benefits from it. So as part of the design process for the population health facility, they have a mandatory eco charrette that they do for their LEED accreditation. And we wanted to expand on that. So we held a charrette and invited students from all different parts of campus, and then invited Chris from Miller Hall, PAE, the mechanical engineering firm, our UW administrators, as well as the sustainability consulting group that were putting on the prior charrettes. And then as well, Site Workshop was the landscape architect on this project. So we had all these professionals at this event, and then we put out this call to students and said, hey, we're having this design workshop for the population health facility. We're going to have these professionals from these different firms. And usually we lure students in with free pizza or food, but actually having professionals there and opportunities to interface directly with these professionals, I think, was a real attraction for these students, and something that maybe sometimes gets missed and you get kind of insulated on the UW campus. But really, this is about developing skills that are going to translate into the real world. So that was a really attractive piece, and I think that was what made this process successful for us.
Thanks. So I'm gonna turn this over to questions to you guys in just a second. I'm gonna have one more just to kind of get them revved up, but have your questions ready. We'll be thinking about what you want to ask them. But I want to come back to Chris and I a couple of years ago worked on some long range planning work. At the time, the Bullitt Center was there because we actually met in the Bullitt Center, which was cool. It's a great building. But one of the things we talked about was these types of buildings are expensive from a first cost basis, and typically they have traditionally not been laboratory buildings or not been these 300,000 square foot buildings. The idea of building an entire campus full of Bullitt Centers just at that time certainly didn't seem possible. I'm super encouraged to see some of the buildings you guys are doing now, but as we think about, we've just added between these 2 buildings like another 500,000 square feet. The campus has 16 million square feet. So, I mean, it's a lot of space. So there's a long way to go. What do we do about the rest of campus?
Well, I'm going to come at that from a couple different directions. And I'll start maybe editorializing a little bit with that Bullitt Center context and thinking about our 2050 goal of having a zero carbon campus. There's a lot of things in a design process that get thrown on the table. We want to do net zero energy, or we want to do net zero water, or we want to do innovative things with the facade and engaging with the way that people use the building. And it's kind of difficult for a campus. We're spending taxpayer dollars. We have to be super prudent with it to understand what's going to work, how it's going to work, how much it's going to cost, what are the barriers of doing it on a campus that's primarily served by a central utility plant and has maintenance structures built around that. And so there's a lot of uncertainty with bits and pieces. And I'm just going to say, if I could wave a magic wand and do one thing that to test the waters, is I would love to see the university commit to building one sort of living building style project on or very close to campus. Because I think rather than doing a lot of studies and doing a lot of evaluation, if it costs 10% more to do that building, that 10% would give us a living building, right? Probably a zero energy, zero water building with lots of great interior environmental quality. So we'd get that for the 10%, but we would also understand what all the barriers and stopping points and challenges are to doing those things on our campus, both maybe for our existing buildings, but certainly for our future buildings. And it would be a much better learning experience than sort of hypothesizing at every step of individual building components. So I feel like if we could commit to, as a campus, to a living building here, that would get us a long way to understanding the barriers and give us a path forward to things that are viable, things that are challenging, and things that maybe we shouldn't do, which we don't currently know. So that is what I see as one viable path forward, or one possible path forward. I think we also have to think about our existing buildings, but I'll leave that maybe to others to address.
Yeah, do you guys want to speak to anything you've learned along the way? Because I think that there's something there, right? It's not just theorizing about how this could work, but just to follow up.
I can talk about that briefly. I think, number one, I love that challenge. I think that fits right well with the work that we want to do. I think all of us along here, and just kind of understanding and realizing too that we're kind of past the point of this incremental change too, which I think Chris is trying to allude to, is we know how these buildings work. There's the Bullitt Center, and there are others. Perkins+Will has one up in Vancouver, and a number of other buildings that perform at these levels. So we know how they work, but it works differently maybe for different institutions, and there's different considerations about maintenance and those things that we have to work out. But in general, we have the engineering concept solved. So now it's time to really make those commitments. And I think you're right on with saying that. So I think that would be great. And I think next it's about really solving some of the more political challenges and how we can all agree that this is the right way to move forward and finding out solutions for those.
If I could add to that, I think we could approach this from two different sides, and I think it's a both and. Yes, we get that really aspirational living building. I'd say let's do that. In addition, how do we get the lowest common denominator raised up? We're doing new buildings all the time, right? How do we make sure that those are meeting a standard that really meets where we want to go by 2050? And I think an individual building, even if it doesn't get all the way there, can set a bar and set some appropriate strategies to get there. So for example, the life sciences building got to, it's the 2030 challenge. For those that are unfamiliar with it, that's getting to, at least at this time, it's a 70% reduction below a baseline from 2003 CBEX. But it was able to get to an 80%, 81% to be exact. So that's the goal between 20 and 25 is going to be the 2030 challenge. So now that there's been a lab building that can do that, all other buildings on campus can say, let's set that as a target. We may not get there, but it can be done, and there's strategies that can get there. And I think that if we do the kind of raise the top up and then bring up the bottom to setting these targets, sometimes we just need to draw a line in the sand to know what we're comparing against. Does every building need to get there? No, it won't. But at least we need to start drawing some benchmarks.
And when we talk about existing buildings, we can even look at just operationally how things are handled too, right? That don't necessarily add expenses, how you can do things more efficiently. If you've already got water consuming fixtures in the building, how can those just be more efficient? You're not having to add new ones or change them out. You're reducing the amount of energy that's being used at the building during off hours, sharing loads in the building. How can we start to strategize with existing buildings just in terms of operation that can be savings as well?
That's great. All right. Who's ready?
So you guys have talked about the big battle is getting the buildings built in the first place, but I want to ask you a little bit about the rest of the lifespan of the building. What kind of data are we getting from these buildings once they're in operation? Are people's behavior and the use patterns ruining the sustainability ideals that are going into it in the first place? Like, what are you guys seeing in terms of the feedback from once these buildings are put in place?
I'll take a first crack at it. So, there's fairly decent data coming out of some of the buildings. Most of them are on steam, a lot of them are on steam heat, and that is notoriously difficult to measure. but we've got a little bit more transparency here. I noticed those of you who are interested in building energy use transparency, you can go to the City of Seattle's website, and there's a portal where you can look at all commercial buildings in the city and click on them and see how much energy use they have. What I will say is there's a big blank area just north of the Montlake Cut that doesn't have any buildings in it, and I'm not exactly sure why that is, but I think our campus should be on that map, and everybody should be able to see that information. From my perspective, the users are never ruining the building. If you're not engaging with them and figuring out if they don't have a way to understand how to use the building or be comfortable in it, then that's a problem with the design or the operations or something. Net zero energy is an operational challenge. And that takes things that the building was designed to enable. It takes things operationally happening the way that they're intended and making sure that that happens persistently, which is a real challenge. The university and the people that operate the buildings here have a huge challenge with that. And then there's engaging with tenants and having them understand and making things intuitive for them and allowing them to use the building the way it's intended to deliver higher and better results. In the end, we don't build buildings to save energy. If that was our goal, we wouldn't build the building. That would save energy. But we build buildings for people to be in and be productive and do the great things that the university is built to do. So you got to be able to hit that goal number one. But I'm confident that we can do that. And these design teams are showing that you can do all of those things and elevate the university at the same time that you reduce your resources. So I don't know who else wants to
jump in a little bit on that. I think it's a great question because on day one it can be one thing, but it's really day 100, 200, 500. So I think that first of all, the facilities folks are absolutely critical to this, and I think what we're finding is a lot really step up to this awesome opportunity. Here's a innovative new building. I'd like to learn about these systems and advance it. The measurement and verification, understanding how is it actually performing relative to that. So there's the facility side, and then there's the user side, and I think part of that can be from the educational component. See Marilyn back here. So there's dashboards that can be a real great way to kind of get that information out there. I'm guessing population health may do something similar, but at the life sciences building, there's a touch screen. You can understand how the energy is performing at that moment. You can compare it against other times. I think that's really critical both from the user side, and the facilities will have the much heavier data-driven side to it. So I think it's a really good question, but I think people really step up to that challenge when they have it.
Great. Anybody else? We can go back.
Kind of pairing off that question of using the data and analytics of the data, what is, what are the kind of initiatives that the schools are using going forward now to almost take the facilities piece of it and making it simpler, making it more automated in order to alleviate things like the future of the facility staff shrinking considerably over the next 10 years, and the knowledge base going along with it. Where is that? Where is the university or the universities taking the use and the facilities operations part of the building and automating it, or utilizing the computer technologies that are out there now?
I'm going to take that one. Just as I just got done with Marilyn with the tour of the chilled water plant on the other side of campus, and largely it's an what did he call it? It was an unmanaged, or there's automated plant. Basically, people obviously go in there, and there was a guy in there working on one of the chillers when we were there, but they've actually designed it so that people are not pushing buttons to turn things on and off. But you guys can speak more to the buildings themselves. How are they? Or how does the maintenance play into it? How does automation? Yeah.
I mean, yeah, that's a whole component certainly of what we try to do, but we try to pair that with the operations of it. I mean, and how people are trained to currently operate certain machinery in the buildings, how they're used to doing things, but kind of pairing that with some of the energy goals that Chris has talked about trying to get to, and then also trying to gather all that data and analyze it. I know, for instance, Chris is analyzing a lot of the data that comes out of the Bullitt Center, and in some cases it's almost too much data, and you have to determine what makes sense, how you can use that and use it to help change either what we design for the next building or adjust for occupants and have them understand maybe different behaviors or how to operate something in a little different way. So it's a continuing challenge that we face as we go forward and have these buildings that, while we strive for them to be more focused on passive solutions, we know that technology will be certainly a part of their design as well.
There's always trade-offs, and I'm looking at J.R. Fulton here, who's in the audience. The central plant largely heats our buildings with natural gas. But one of the benefits of having a central plant is it's easier to centralize the maintenance. You've got hot water, steam headed out to the buildings, heating those buildings. You don't have a lot of equipment inside there that you have to maintain. But when the university started building the new campus housing in West Campus, they did come off of that, and they've managed to do some really, really efficient buildings not connected to the central plant, and have found ways to operationalize that in a way that is viable for the campus. I know there's a lot of thinking going into the central plant. Maybe I'll pitch this one back to Dave, who's looked at a lot of campuses and helped them shape a trajectory to getting to a low carbon future. And that includes this mix of are we on a central plant, or are we doing localized all electric heat pumping in our buildings, and how do we transition into a low or no carbon future? So you do a lot of work there.
Well, the typical answer, or the quippy answer, is you electrify everything and then you clean up the electricity. Although if you live in Minnesota, that may not be quite as easy. But that's, I just saw Carleton College give a presentation 2 weeks ago, and they basically electrified their system. And I mean, it's doable. I guess maybe leads into another question that I want to ask you guys, especially here on a campus situation. We like to think of these buildings as these award-winning projects, but they are part of the bigger ecosystem of the campus, not only in terms of their energy use, but just in terms of their general use, obviously. Chris, you've done a lot of work on this with the living building work you're doing. How do you think about these buildings not being individual instances, but being part of a broader network of systems? It's a much challenging problem, I think.
And that's a good question. We run across that question, I'm sure, as you do every time we do a new building on a campus. It's, will it connect to the central plant or won't it? And it is a balance of a lot of things. There's resilient strategies to consider. There's determination of whether the plant that's existing on the campus is going to be upgraded before your individual building will. And then sometimes just district solutions may not be the right one, and building-centric solutions may be better and more efficient. It varies from campus to campus. I don't know if you would agree with that. And the goal for the buildings always vary, but I think we always start with the idea that we have an efficiency target in mind in terms of both energy and water, and we are trying to get more ideas about resilience into that as well, and this decarbonization overall. How can we reduce both the operational energy of a building and the embodied energy of a building, and what are the ways that we can do that? And it varies from campus to campus depending on your energy system too. We have great clean energy in the Pacific Northwest. Other campuses, as you allude to, might not. So it's really quite varying.
Go ahead.
I'm going to add something to that. And this is again to the students, and maybe I'm going to pitch it to Kyle, or maybe back out to you guys. You've seen some of the land use action signs around campus that say we're about to build 6 million new square feet of buildings on West Campus and on East Campus and all around. And these questions are very pregnant in terms of how these buildings are going to be powered and built, and what the energy sources are going to be for them. So there's that. But the other thing I'm going to say is, having sat in on some of these charrettes with the design teams and the campus planning here, the students' voices, in a way that my voice doesn't get listened to, and maybe some of the consultants who are kind of pushing a sustainable agenda don't necessarily get listened to. But when Kyle and his crew show up, the ownership side, because they're building for you guys, you're their constituency, it perks their ears up. You might not get everything you want, but you definitely get listened to in a way that some of us don't. So it's a really, really ripe time, if you're interested in making change, to raise your voice, because we're about to build a ton of buildings. All those cranes in South Lake Union are going to get moved over here and build that new campus plan for West Campus and elsewhere. So the time is right to raise your voice if you want to make change. And CSF is a great venue for that. Yeah.
See, I told you you'd give an impassioned speech.
Yeah, that's right, the clapping. To add on the optimism side here, a campus setting, this district scale thinking outside of campus, downtown, South Lake Union, it comes up in almost every design discussion, but it's really hard. A campus is actually set up much better to accommodate that. You know your neighboring building, you know who's running it. They talk to each other. Oh, I can put some PBs on your roof and you can use my water for this. We're trying to do that, and this is really set up for it here. So I think it's a fantastic opportunity. One, you get the students' voices on and you start knocking on your neighbors' doors and saying, what's a waste you have that we can use as a resource, and hey, we've got some of this for you too. So I think it's a fantastic time for that.
Cool. Go ahead.
With these zero energy buildings, do you ever think that they will be completely self-automated to where we won't need a whole group of faculty to like sustain the building, and it will like be down to maybe like 1 or 2 people running the entire building?
So I'm going to respond to this question, maybe address a couple of the other earlier points about facilities maintenance, and then I think to your question about automation, there's a lot to be said for automation and also the centralization of some of these systems. There's purple pipe systems and talking about rainwater or gray water or even black water and thinking about how we can centralize that instead of looking at a parcel to parcel basis. So in a way that is automation, because you have a lot of maintenance needs with having individual scale gray water, rainwater systems. So that's one way I think that these systems are going in that direction. For more ecological systems, I'd like to remind us that having jobs where people are maintaining these systems are actually really important, because we're building a culture where people are technically savvy and also employed, and they have jobs where they're able to teach students about these systems and the technical ins and outs of them. So I think while there is a place for automation, it's also really important that we have people that understand these systems and have jobs that are dedicated to these systems. And I think that builds a culture within the university that is really important if we want to continue to see these types of things happen.
Yeah, and I'll add on to that. I think I see some other folks that manage buildings for a living here, and at least from what I'm seeing, they're always looking for more staff to do this work, not less staff. I mean, the fact that these buildings are getting more complex does not mean there's less people working on them. It's kind of the opposite. It's just that the buildings can do a lot more, they function a lot better, they're a lot healthier, and they're just better buildings. But let's see, I'm going to go right over your head. No, you got it. Yeah.
Yeah. So I was wondering, for the university folk, what you guys are working at quite a high level of sustainability on this campus already, and what sort of advice would you have for smaller campuses or private universities on how they can sort of build that and take those first steps? And then for the architects, when you're working with clients who maybe are not at this level, then what sort of strategies do you employ to bring in the sustainability aspect, and is that working?
Great question.
Take part one.
Yeah, I'll take part one. I think the first thing that I think is worth doing is just to understand what your energy use and water use patterns are existing. If you're not using, are you familiar with the Portfolio Manager tool? Portfolio Manager is a free web-based interface that the U.S. Department of Energy and Energy Star has put together to allow you to understand how you're using energy so that you can make better decisions. So it just can tell you where you are, maybe give you some hints about where you should go and create a plan and stick to it. But the first thing is just knowing where you are and having access to your data so you can make informed decisions.
Can jump on the part two of your question about from the design side, what are some of those opportunities and processes to make sure you can get sustainable buildings? Chris touched on a little bit earlier, having an eco-charrette, a sustainability workshop. What we found actually is having a second one. So typically at the kickoff, maybe at the end of concept design, beginning of schematic design, we'll do an eco-charrette. What's critical is at that point to say there's going to be a follow-up one midway through design and design development where we're going to come back to all these goals and we're going to talk about specific strategies of how to get there. And that's what we've done in the life sciences building, and that's where the solar panels came from. That's where the water reclamation came from. At the beginning, you may not have those, but you can't skip that first step either. So one, I would recommend the 2 eco-charrettes, but 2, you can also bring in outside consultants to support in that. And I think that would be an opportunity. You look at who you have around the table from the engineering and the architect side and say, we're missing a gap here, and bring them to the table for those discussions. And I would also include the students in on that too, because the second eco-charrette is when we brought the students in. They actually presented out on case studies of integrating solar. and talked about the grant opportunities, and it blew away. The client was like, oh my goodness, this is fantastic. So bringing the full team, open the door is really what it is. Let's bring more people in.
I'll just add one other point is Dave's specialization is looking at how groups of buildings and campuses use energy. And I assume you do that at multiple scales from the big to the smaller. So you might have some, I'll toot your horn for you.
Since he's giving me the lead in. Yeah, I mean, one of the things we talk about a lot with campuses when we work with campuses is that you don't have to do deep dive hourly data studies on every building to make some change. I mean, most of the time, if you know, they were talking about earlier, just basically what do you have? I mean, it could be as simple as what are our buildings and what kind of building are they? And we can just estimate what kind of energy they might use. Then let's focus in on what are those big users. I know here at the University of Washington, I can't remember which part, it was like part of the, I think hospital is the biggest energy use by far. JR could probably speak to that. But I mean, there are certain things that you want to, okay, well, let's focus there. And then, guess what? There's a whole bunch of concerns about health and safety and other things that we can't really get at that building, so let's work somewhere else. There's a lot of things like that you can figure out without having to do expensive studies or whatever, and it's just about getting a basic sense and getting that basic sense in front of a lot of people that are not normally at the table. I think that's a key point too. Most of the time when we're doing our work, we're introducing people from other departments to each other on the same campus. It's ridiculous. It's like I'm coming in from out of state and introducing them to each other when they live, they work in buildings next door to each other. It's kind of silly.
And I would just say, backing it up from a very generic level to where you can start is you as owners have a lot of power. And so this sounds self-promotional, but it's not, is to hire the right design team first. So find a good architect and good engineering partners that can help you do this. And they're going to help you get to the goals that you want. And the second piece is, even if you don't know what those goals are, those people, if you've hired them correctly, can help you figure those out. And I would say that not to be afraid when you're in your design meetings or your very initial meetings about whatever the project is to ask questions. You don't have to be an expert or an engineer in these things. I'm not an engineer. I certainly ask their expertise just to say, how can this be better? How can my building perform better with energy? How can we use less water? By just simply asking these basic questions, you can kind of set forth the standards, especially you from an ownership side, to really help drive the building forward. And just keep after that and do that as your building progresses.
I'm going to add just one quick thing to that, to your question. So UW, as part of the Population Health Facility build, actually developed a Green Building Standards Committee with various administrators on campus. And Chris Meek here, and I think both the Chris's here were on this committee, and they actually created energy and water targets for the university that they didn't have previously above LEED standards. So that's 15% above Seattle's energy code and 50% above Seattle's water code. So I think going forward, having those standards are going to be really important. You can have an eco shred and be pie in the sky and have a million ideas, but having clear standards and goals for your campus, I think, is really important. That you're all on the same page and can shoot for those standards.
All right, let's see. I'm going to go back here, over here, and then way back there. So go for it. Yeah.
Okay, so when we're talking about presenting to the students, how do you guys present that information to them? I know I look at engineering plans and designs, and I know that it's not always easy to look at the concept from that. So how do you kind of break down the information in those charrettes with the student group?
Go for it. Yep.
Yeah, typically, I mean, the charrette level is not really starting at the detail of looking at plans or detailed engineering schematics. Really, we're really at high level, especially those introductory charrettes that Devin talked about, is really just setting the goals. And as Kyle mentioned here, having the university set these basic goals of, you're going to be LEED whatever, you're going to have this much reduction in energy and water, is really kind of a great starting point where everyone can get involved at. And we're not really looking at detailed plans at that point. We're saying, okay, we've got this energy goal. How might we get there? Let's make sure the building is naturally ventilated. Let's make sure we have daylight sensors. Let's make sure we're well insulated on our envelope. And I think these are discussions that general public can really have and that people can chime in on. And so I think there's availability to do that. So don't be afraid to be engaged in that way. It's only really as the design progresses into these further stages that Devin talked about, where we really start to figure out from those initial charrette goals, how do we make the engineering and the architecture work?
Yeah, if I could add to that, it's actually you guys doing the drawings. What we'll do is we'll first of all talk about overall goals, and we'll break out and we'll have little flip charts like this, and there'll be a cluster of people that are passionate about water, and we'll make sure that there's folks from the design team that are there, but everybody else who's interested will be sitting around there, and everybody's got a marker in their hand, and they're sketching through whatever makes sense to them. They can write words, they can draw a section if they can draw a section, whatever they want, diagram it. So it's a brainstorming exercise, meaning there should be nothing kind of stopping that.
These guys are both amazing architects and work for amazing firms. And you look at the plans, you look at some of the drawings and some of the stuff, and it's hieroglyphics. But ultimately, it's about getting to what the stakeholders want. You don't need to know anything about architecture to know you want a view. You want natural light. You want an openable window. You want to meet these social goals of how much energy you want to use. Those are things that everybody knows. I mean, we spend 90% of our time in architecture. All of you know indoors, so all of you know a lot about architecture. It's just about expressing what you want. These guys are the ones that translate it into the beautiful buildings.
Yeah, I have a secret dream that instead of storming the president's office to demand for 100% on-site renewable energy, people will say, we want natural ventilation or something. It just doesn't, it's not as sexy. All right, I had a question over here.
What kind of retrofitting have you guys done or can you do for the existing buildings that's economically feasible that other universities can do without a giant budget?
Right, so retrofitting without a giant budget.
Yes. Any idea? Are there any?
Yeah. I mean, anybody else wants to give it a shot? You can get usually 15% savings just by making the building work right. A lot of buildings are operating broken. So you can get 15% on anything if you tune it up every 2 or 3 years, because they start to drift toward broken again after every time they get tuned up. So there's that, operationally running the building right. But gosh, you walk around on campus, there's no shortage of buildings that could use new lighting. There's no shortage of buildings that are single pane windows that need new windows. There's no shortage of buildings that need HVAC upgrades or et cetera. All of these things need to happen. It's a question of money and how you spend it and how you stage it. And if you can stage it in a way that's synergistic so that by the time you spend money, you get a better building. You're not just replacing something that looks the same way it was in the 1960s. I think we could make every building on this campus meet the current energy code with a modest tiered investment over time. The University of Washington is a university of 1,000 years. So when you talk about economic feasibility, what's that timeline? Is it 3 years? Is it 1 year payback? Or is it 10 years? The 10-year payback is going to get all the things that I talked about. So if we can look at 10 years, and I think everybody think we're still going to be here in 10 years. I hope so. But I think it's economically viable to get all of our buildings, and they'll be more comfortable, they'll be higher quality, they'll be better service to the people that use them. So I think all of that is doable. We have a tool that helps identify those things too.
Well, I talked with somebody from the SUNY system a couple weeks ago, and they were doing cladding, which is like fixing the outside of buildings, with what she described as sort of like a bath fitter type product. So it was like you would just bolt this stuff onto the side of old buildings, and supposedly they could get past the architects and they could make it beautiful. But there's, I think, new technologies that people are realizing that there are different ways, newer ways to retrofit. But I think from my perspective, I love the cool new buildings, but that's where I lose sleep at night, is what are we going to do about all those things? And I think I'd like to see more motion in that.
The other thing is we've got a lot of older buildings that are beautiful buildings that we want to keep, and it's that investment, of course it's economically feasible to do it because we're going to keep those buildings and be operating them forever. So anything with a 20-year payback is like heresy often, but a 20-year payback is something we can live with because we know that the quad is going to look pretty similar to what it did, I hope, what it does now in 20 years, so it's worth making that investment here on campus.
Cool. All right, I forget who else. Go ahead.
You've all been able to share about student engagement strategies. Could you speak more to the community engagement strategies?
Sure, I can start. So that is a tougher one, I will say, and one that we were not fully successful at. I think there's a lot more work to do there, not in just our University of Washington projects, but in all of our projects. I think understanding the best way to reach out to the community is tough, number one, but then getting the right engagement level and getting the right people to the table, getting the right community members involved is really, it can be a challenge and something I think that we're still working on, just to be fully transparent about that. And we did certainly have that here. We had some times that the community was invited to open charrettes. We had an integrative health process for our building that was performed, where we had not only health experts on campus, but others from the community that were part of the participatory process throughout the design phase. And then I think the challenge is back on the design team, trying to integrate those ideas and make them show up in the project for the long run. But it's something we're still working on.
You know, one thing I'll just add, and I'm a little bit of a broken record here, but this, at least for the campus and the decision making here, the community engagement is the students, and the students are engaging through CSF. CSF provides a vehicle to have the students' voice front and center on a lot of these big building decisions. I think, however, as we move our development west of campus, there's going to be much more external community engagement. Yesterday at the Gould Hall, which is the College of Built Environments, there was an event around Save the Ave. So thinking about, as we transform that neighborhood, what happens to the Ave and all the independent businesses there? How does that fit into the future planning of the university? And there's some challenging decisions that are going to have to happen with that and engaging the community.
I mean,
go ahead.
It's a really quick one. I think on campuses we actually don't frequently. I think the community is typically the students. I think it's a great question. Off campus, there are some good examples. We're doing a project on the waterfront, and so we brought in Seattle Waterfront, Friends of the Waterfront, to a meeting before anything's been figured out. It's still kind of a fresh idea. Then we actually invited folks within that community to come walk the site with us and talk through it. So I think, and that's becoming part of the design review process too. So I think as a city, we're baking in some of that community involvement. But to my knowledge, it's not necessarily happening on the campus side.
I'll speak a little bit. The opening note speaker this morning, Lisa Gromlich, mentioned one of our projects, ethnoforestry project that student Courtney Bobson, she's a PhD student at the School of Environmental and Forest Sciences, has been working on. She's working out on the peninsula, working with the tribal communities out on the peninsula, and the Department of Natural Resources and the Olympic Natural Resource Center out there. So there's kind of these true intersections of the people whose land that we're on and their traditional practices, and the curriculum here at UW, which is predominantly, I'm a horticulture student, the plants we learn about are mostly at the Arboretum are exotic plants. So her focus is looking at ethnobotanically important plants to native people here and bringing some of that to campus with new planting projects. She's working with the Burke Center on their planting design. It actually will be a part of the Arboretum, so it'll be a permanent planting installation. And that carries forward, I think, with kind of our thinking is, you know, how are we taking that knowledge and the knowledge of people within our community and those important perspectives, particularly of marginalized people, and including that in these planning processes. So I think there is opportunity to include that in our planning process and really upfront in the planning process. And again, as Chris mentioned, with expanding to West Campus, you know, that we're more on that buffer zone where we do need to be more responsible about what impacts we're having there.
Great. Go ahead.
So I'm thinking of pursuing an environmental engineering degree. Is that, do you guys utilize environmental engineers more so, or civil?
Okay, so environmental engineering or civil to get involved with this kind of work, is that what you mean? Is that the line of the question? Okay.
I have not used an environmental engineer specifically on a project. I don't know if you do. Typically, we use civil engineers, and when we do, we try to find the right ones, of course, but ask them to focus in certain areas depending on the project. So it's usually not outside of that discipline that we look, unfortunately.
I'll just add that we understand it's actually more of an ecologist. We've folded into our firm an ecologist just to give that additional perspective. So it's not exactly on the environmental engineering side, but so I think in general there's a trend towards trying to look beyond what we typically do day to day to give another perspective. But I think to get to your first question, I think the civil engineering is definitely the most straightforward route to getting to the greatest impact right now.
Yeah, just to add on, environmental engineers, I mean, from my understanding of it, I'm a software guy, so really take this with a grain of salt, but I think they were mostly working on like reclamation projects, like where there's
Soils.
been like, big, what do they call those, Superfund sites and things like that, versus, I don't know, maybe somebody else can correct me there, but where, civil engineering definitely intersects more.
I will just mention when we do specific buildings, like if we focus on living buildings that are looking at net positive water systems and on-site water treatment systems, we are looking at a little bit different engineers. We use folks that are more specialized in that water reclamation and water engineering specifically designed for those systems, a little bit more outside of civil engineer. In the past, I've used a civil engineer who has a crossover experience in some of that expertise, but unless we're kind of going down that specific road, yeah.
All right, we got one more audience question, and then I've got one to kind of bring you down and one to bring you back up.
Just looking at the life sciences building, I was wondering, how does insulation work in a building that's made primarily of glass?
Yeah, how does insulation work in a building made primarily of glass?
So yeah, twofold. So the glass that you're seeing is a very high performance glass. So there's what they call low E coating, which gets applied to it, which helps from an energy efficiency. And the glass itself is high performing. The curtain wall system, not this portion, this is actually a point supported glass portion that we're looking at right there, which is also high performance. But yeah, so this portion is using a curtain wall system. And I don't want to get into the details of it, but there's these starter sills and thermally broken. There's a lot of detail that can get into making the glass actually perform quite well. With that said, where you can put solid, we do, and in those areas you do make sure that you're doing well insulated. But stepping back, it's not just about packing insulation into a wall, it's actually a lot of those kind of three-dimensional conditions where things come together, where you get your air leakage, and actually a lot of the performance can drop immensely. So we spend a bulk of our time, and we'll bring on envelope consultants, so that helps immensely with that, to really look at those conditions and make sure that they are performing as we anticipate, and we test them. We actually did quite a few tests, both on the glass as well as on other conditions, to make sure it's performing as we would like.
Great. Anybody else? Okay. One of the things that I know I've run into quite a bit when talking about this topic is you have building codes that can be helpful because they're pushing you towards better and better standards, but oftentimes you'll run into the opposite, where there's safety codes or other codes that are there to protect the public, but that get in the way of really pushing the envelope, in not the literal sense, with some of these projects. Can you guys speak to some of those that you ran into with these projects, maybe how you have overcome them? So I guess you can be downer and then an upper.
I can start if you want.
Sure.
If you want to. Sure. Okay, so from the code standpoint, I'll actually put a little bit of a positive spin on this. There's a shift that's happening when we look at from a water use. So typically the stormwater, which is the rainwater coming, can get treated and reused for toilet flushing and for cooling towers and irrigation. But gray water, which is water coming from the sinks and the showers, typically, when it's called gray water, actually is only intended to be used for subsurface irrigation. But there's a shift now in the codes towards looking at it as reclaimed water. And what reclaimed water is shifting it from gray water, which sounds like it has challenges, to a treated system. So that can get used. So it's not on this specific project, but on another one, we are using treated gray water, once again, for those non-potable uses, such as toilet flushing, irrigation, and for cooling towers. So there's a shift code-wise to allow more of that. And I think that's critical, because if you're just waiting for rain to fall on your site, you're really limited in what you can do. But if you're looking at the uses in the building and bringing that right back in, as climate does whatever it needs to do, we're a little bit more resilient in that way, that we're looking at systems that are set within it. The next step then is looking at making it potable, right? Whether those are things that we could be drinking, et cetera. And I'm actually quite happy that they are conservative about that, and others may feel otherwise, but I think it could be a huge health hazard if we just go beyond our skis on that and allow anybody to go there. So I think we'll get there. I think we have to get there, but hopefully it'll be an appropriate scale and an appropriate time frame.
I'll also have a positive spin on the codes too, is I think that they have really been helpful to us to get the buildings that we want. And I think if you are running up against, in terms of sustainability, if you're running up against codes where they're a problem for you, you're probably not pushing hard enough in energy and water, because they're pretty achievable, especially in most districts outside of Seattle, but even in Seattle where we have some of the most stringent codes, we can do these buildings, as I think we've all mentioned. So I think they're really helpful. We like them as designers to help push us. And then as Devin's saying, they're starting to expand in terms of water just really understanding how we can collect and treat rainwater better. The Bullitt Center, which my firm designed and Chris works in, they can now drink their own rainwater. That's the only commercial building in the country that's allowed to do that. They've had to go through the right public health steps to be able to do that, but that's starting to change the conversation around what's possible in water, and hopefully the codes for the rest of the buildings will catch that soon. So I'm an advocate for good stringent codes.
Yeah, I'm gonna echo that, and the codes have been a great help in a lot of ways. They've wrung 97% of the electricity out of lighting in the past 25 years. It's pretty amazing. They're squeezing heat loss energy out of buildings. We're saving on HVAC. We're being required to put more efficient systems in. That's all driving energy waste out of buildings, and it's getting the amount you can save through innovation is getting smaller and smaller and smaller. But one of the great opportunities is to start to engage the occupants more. That's where more and more the total building energy is happening through things that the occupants do, bringing computers in, the way they open or close windows appropriately, or engage with other components of the building. So the new frontier is really working with people and how they use buildings to save energy as we get more and more of the prescriptive things out of the way, like envelope, lighting, HVAC, et cetera. So it's an opportunity for all of you.
Actually, I'll build on the user side of it a bit too. For the life sciences building, we were looking at what is that threshold where we can reduce our plug loads, right? That's what we can have control as the occupants. And what we came across, and this is kind of an eye-opening experience for me personally, was the research that's happening at this building is on climate change. If we reduce their plug loads and their comfort ranges are so out of whack with what they're comfortable with, they're not going to be able to do the research that they should be doing. And they may not be able to do as well. So actually the most responsible thing from a larger holistic thinking is make sure they can do their research, and then let's look at all the other opportunities for the sustainability. So it's the HVAC systems are very efficient, but the plug loads, we just trimmed down to a spot that was comfortable. It did not seem right to let the people trying to write their grants not feel comfortable in their own space.
Excellent. All right, so just wrapping up, maybe I'll round robin, and maybe Kyle, you haven't had a chance to talk for a bit, so I'll let you start. What do we have to look forward to? What is our built world going to look like in your maybe perfect vision or your realistic vision? Maybe to give us 2030, 2050, whatever you want.
Yeah, I think for me, the built world is one that prioritizes equity and collective identities as well as innovative technology. So I think maybe something that we didn't talk to as much today in this conversation is how does the built form represent different identities? And so I think including more people of color in this field that maybe aren't as well connected to STEM in a lot of cases, and ensuring that those voices are heard in this conversation, I think is going to be an important step going forward. So just want to acknowledge that, because we didn't spend a lot of time talking about that today, but I think providing more opportunities for diverse perspectives in the built environment and really thinking about the built environment creatively from a place that's truly representative of the people and the occupants that are using those buildings.
Devin, you want to go next?
Sure. So, and this was touched on earlier, that we've been kind of going through incremental change, I would say, from a sustainability standpoint, and we're really on the verge of monumental change. It's happening. We have to. It's a necessity at this point. And what that's going to look like, I almost feel if we try and say it looks like this or that, is actually going to restrain us. I think what the hope is, like I've had people say, oh, what's the style of this thing going to look like? Like, we don't know yet. We're looking at each facade to just try and do what's best for what it is. So I think this idea of a kind of rubber stamping or some style is really going to go to the wayside. We're going to be looking at specific necessities for that building, that type of building, whatever their program needs are, that specific site, what are the orientations, what are the needs, and we're going to come up with some, not we, all of you too, students, et cetera, are going to be coming up with something that we have no idea about. And I think we just need to kind of let that happen. It's more of a release. But monumental change is ahead of us. Let's make a big splash.
Yeah, on that front, not to be too much of a broken record, but we've got 6 million square feet ahead of us here. And those of you who are students or faculty, but definitely, especially the students and through the CSF, you have the opportunity to shape what that looks like. And a lot of that is going to be, those decisions are going to be made by folks on our campus, but a lot of them are also going to be made by other people in the build community. A lot of that's going to be public-private partnerships, and your voice is incredibly valuable and can shape the nature of what that is, and that's going to define our future in a lot of ways. So I encourage you, through Kyle, through other channels, be the voice to ask for what you want in the future.
I think quite simply for me, it's buildings that will emulate nature and then give back to nature without taking from it, and remembering that we as humans are all nature as well too. So I think that is, while we often forget that, I think we make things that are not really natural, but that helps to address some of the equity pieces as well.
All right, well, great. Well, so panelists, let's give the audience a round of applause. So good questions. Yeah, good. All right, and if you would all give our panelists a round of applause. Thank you.
That's it for this episode. I did want to give a special shout out to Abby Lynn for Bellevue College and Kevin Laycock from my staff for their technical and logistical support in making this podcast happen. I also wanted to thank the sustainability team at the University of Washington for putting on an amazing conference and giving us this opportunity. To learn more, you can always see the show notes at our website at campusenergypodcast.com. You can follow us on Twitter. We are at Energy Podcast. This show is a free service, but if you'd like to support the show, please consider leaving a rating or review on iTunes, or just telling a friend about the show. As always, thanks for listening.